a video, but whatever. So the key thing in these problems is sort of setting them up, isn't it? So, how are we going to set this up? There's different ways of doing it, aren't there? So we've got the profit function, which is 16q minus 2q squared minus a squared. And then we've got this. So, what's the next step in this?
So you can rewrite I as a restriction?
Yeah.
Do a Lagrange?
So I think, in general, we're doing a lot of Lagrange, aren't we? So why don't we say that, look, we've got a Lagrange which says this, but also this has to hold, so we could call that I bar. So then we can just say, look, lambda I bar minus 4 minus 3a plus q. So that's the math. And of course we can all solve this now. So what are we going to get? dl dq is 16 minus 4q. Oh, this is where I went wrong, isn't it? Plus lambda equals naught. So that's like one first order condition, and then the first order condition in A is going to give minus 2a minus 3 lambda equals naught. So if we multiply this by 3, 48 minus 12q plus 3 lambda is naught. So we add these together, 48 minus 12q minus 2a equals naught. So we've got an equation in q and a, and then we've got this in q and a and I bar. So then we can solve. Okay. But it's like we're kind of doing it a bit blind there, aren't we? It's like, what's really going on? Have we found the right answer? If we're concerned about that, how could we check that? Perhaps we should just find the answer. So I hope I got this right. If we multiply this by 12, we get 48 plus 36a minus 12q equals 12 I bar. So then we need to subtract one from the other to get rid of the q's, and we're going to end up with 38a equals 12 I bar. Is that the right answer? Don't recognize that. It's not. I'm trying to do this too fast. 48 minus 12q minus 2a, 48 plus 36a minus 12q. Da da.
have the values for Q and A.
So what should A be?
A is 6/19 I bar. And then Q.
Yeah, well, that's right. Yeah. We divide that by 38. Yeah, that's fine. Okay, great. Thanks. Okay, and Q then we can put that back in, and Q is
4 minus 1/19 I bar.
Or
Wait, no.
4 and 1/19, I guess.
Yeah. No. I'm not sure.
Okay. I've actually got the crib sheet here.
I've written 4 minus 1/19 I bar. I'm not sure if that's...
That sounds a bit odd, doesn't it? Oh, well, I suppose it could be. Okay, yeah, no, that is what I've written in my in my crib sheet. Yeah, 4 minus the 19. Don't know why I wrote it like that. Okay. Is that the right answer, do you think? How can we be sure that it is right? I hope it's right, but like, what do we do when we take first order conditions on a Lagrangian? This is kind of what I want to get at right now.
Maximize profit.
I mean, in general,
We're finding the highest, lowest point.
we're finding a turning point, aren't we? And it's a condition for an internal optimum. Like, if there's an internal optimum, it has to be at that point. Okay. Because we found the turning point. But we don't know, just by doing that, we don't really know anything about whether it is an optimum or not. Okay. So how could we find out whether it actually is the optimum? So what's the alternative if it's not?
We check for corner solutions.
So there's one alternative is that it could be a corner,
Could be a minimum.
or the best solution could be a corner, and the other alternative is that it could be the wrong turning point. So it could be we might have maximized costs. So how could we think about that? If we go back to the cost function. Oh no, that was the profit function, wasn't it? No. Yeah, profit function. So if we think about profits against Q, how's that going to look? So when Q is naught, what are profits? And we'll set A to some. We can set A to naught, or kind of forget about A for now. For a given value of A, we're taking out one dimension because I don't want to draw. If we had a computer, we could draw a three-dimensional picture, but we don't want to get that. So let's just set A to naught. So Q's naught, profits are 0, yeah. And then if we raise Q, below Q, this is going to dominate, yeah? but then as Q gets bigger, this one takes over. So it's going to have this shape, isn't it? And if we plotted profits against A, for Q is naught, it's just like, well, it's actually like that, isn't it? So broadly, we can say that we've got the shape that we want, right? That we've got the second derivative is negative. If you're going to do this properly, you need to set up a Hessian and stuff. Has anyone even heard of a Hessian? Julia?
Yes, that's fine.
Tell us what a Hessian is. No, I'm just
Don't ask me about
no,
it.
don't worry. We're not going to do that in this course. It just occurred to me standing here, my God, like if we were going to do this properly, we'd need to set up the Hessian matrix. But it seems that's beyond what we should be doing in this course. But this is really simple because of the independence between A and Q. You can almost treat this as two separate problems, can't you? It's like, what's the turning point for Q? What's the turning point for A? Pretty much. But then slight trickier parts because of the restriction. Yeah, so you can't quite do that. But basically, with these negative curvatures, we can say that, look, and a linear restriction, we can say that this is going to be finding the profit maximizing point. I should have changed this because it's not really, well, oh, okay, no, it's fine. So we've set up the Lagrangian, we've solved for these, and now I think I understand what you mean by, then what's the cost? Yeah. It took a while, but I finally got there. So how are we then going to find the cost? Well, I guess we just stick these into the cost function, don't we? Which is, if we put minus costs, it's that, yeah. So we put in Q is 3 and 18/19 I bar, and A is 9/19 I bar. And put that into there. So then we're going to get, they're both squared, so we're going to get something times I bar squared, aren't we? So it should be 2/19 I bar squared, I think. Although, well, yeah, actually, okay, yeah. Yeah, now because that's not how I answered it there, is it? In my crib sheet or on the video. Yeah, so it's actually it's kind of ambiguous, this, isn't it? So where's the ambiguity coming from? Any thoughts? So like, I was thinking about the costs, and I thought, well, if we want the costs, let's look at the cost function. But actually, it's costly for the firm in terms of profits to reduce its production, isn't it? The firm is going to lose profit by cutting production. And actually, I mean, if the firm cut its production to zero, I mean, that would reduce these costs. But it would also cost the firm a lot because it wouldn't sell anything. So what are we really after here? I guess the interesting thing is to know how much profit the firm loses. So then we should just compare the profits given this solution with the profits when the firm is maximizing, when the firm doesn't have this restriction. And what are those profits? How do we get those profits? The answers here.
Did we put it back into a public function?
Well, I mean, if we wanted to do it, if we don't want to think too much, then we could just do this again, right? But wipe this out. It's probably the easiest. So then if we just did this again, but wipe this out, what would we get? Clearly, you're never going to do any A, because it's minus A squared. So why would you do that? It's just you're losing profit for nothing. So we can just take the first order condition in Q and find that 16 minus 4Q equals 0. So Q is 4. And A is 0. So that would be the way to do it if you don't want to have to think at all. And that, yeah, you might as well do it that way. Another thing you could do is say, well, let's imagine the restriction isn't there. Then it's as if I is 0 or something. We could put in I bar equals 0 here, and then you get A is 0 and Q is 4. But that would be like, is that really right? You'd need to be careful there. Okay. So what about these alternative instruments? What do we expect to happen here? So we're not told anything about the damages, are we? Here. So we don't know what the social optimum is. But then we're told that the government, in its wisdom, has decided on this target. Give me some thoughts about these different ways of getting there. So which of these ought to be socially optimal? So in this one, the government says, look, you have to produce 8 units of I. Otherwise, apart from that, get on with it. Do what you like. But I want 8 units of I. In this one, the government says, look, you have to put a certain amount of effort into making I. And that amount of effort, you're going to have to work that out, aren't you? And that's a trickier problem than this one, isn't it? In this one, you say, look, we'll pay you for each unit of I that you make. And in this one, we'll tax you for each unit of I that you don't make compared to I bar. So this is really important actually to get your heads around this. Which of these are going to be socially optimal?
One of the two letter ones.
You reckon the two lighter ones? So generally you tend to think, or we tend to learn, that the tax the firms for their emissions, or in this case for their non-provision of the public good, or subsidise them, it should be optimal. So you're right. But one of the others is optimal as well.
First one.
The first one is optimal. You're right. Because it, again, there, you're saying to the firm, I want this stuff, 8 of them, and get on with it, And then it's up to the firm to allocate its resources of Q and A, so to speak, or make the choices about Q and A to minimise the costs or to maximise its profits while meeting that restriction. So the firm has still got the freedom to make choices about Q and A. Whereas in number 2 there, you're telling the firm what A to use. So you're like, but then you're letting it choose Q freely. So it's going to end up, how would you explain that? Can anyone explain that? Why does it end up wrong, so to speak? Why doesn't it end up at the social optimum? It's not going to end up at the social optimum.
I guess it has to do with the fact that they can choose how to allocate their efforts.
It does.
In a way that maximizes.
You see, the thing is, the optimal solution involved both providing some A and cutting some Q. So if you just told the firm to provide this much A, because this is the social planner's solution, right? It's just the way to achieve it at the lowest cost. So this is what the social planner would tell the firm to do. But if you just told the firm to do this, how much Q would it produce? So if you told the firm, do 9/19 I bar of A, how much Q is the firm going to make? You need to look up here. Have a think about it. Okay, talk to your neighbour. If you tell the firm, the regulator tells the firm, do 9/19 I bar of A. What choice is the firm going to make about Q?
Ja. Men alltså jag tycker så här,
What I want you to do is
eller vad man
find
ska
the firm problems rather than solve them.
Environmental impact.
Yes.
I mean, it's actually
Jag vill att
Q would be 4 minus 8.
What's the firm's problem? Firm no
Men
longer
tänk
has
på
any
det.
För nu man får ju tänka omvänt. Men
Tänk att det är
So you're going to choose Q now.
bara för att de finns så få då, så
No,
Gonna choose Q.
nej, det är en ekonomi.
så det blir mer så
Then what's
ser man.
So you're going to
think about the firm's
Men
profit
A
maximization problem.
skulle väl kunna vara, fast i den listan, det är något jag producerar också.
Jag tänker,
Är det något du tänker?
nej, det där alltså.
Ja, kanske då vi är
Men vi ersätter det.
annars så
I think it was
då har
Det är inte bättre än något.
Because it's our
Alltså, ja, det är väl de
Nej, men det är ingen
Men då gör vi
so
Ja, men det är inte
assume we will calculate
så det känns svårt att tänka på just vad är det här?
Nej,
Ja,
ja.
then,
Vad är
then
deras
we also should
så
calculate.
det
Det
är
känns
jag vet
han måste
inte.
avgöra vad kul för det är
So,
så
and then it is depending on what you really want.
So what's firm profit? What's the expression for firm's profit when A is given?
When when this exact A is given, it should be the same optimum, or
You think it'll be 4 minus I bar over 19? That's why I'm examining the
Ja,
Okay, so this is useful then, good.
Because you're all wrong.
What is, if we look at the firm's profit maximization problem up there, it's this, isn't it? Pi is 16q minus bracket, it's got really unclear, but like that, yeah? Minus 2q squared plus a squared. Okay? And now a is just a number, yeah? Because the firm is just told what a it has to use. So that's now a constant in the firm's optimization problem. And there's no Lagrangian anymore, yeah? Because it doesn't have any restriction to deal with or whatever, other than this sort of restriction on A, which is so simple that we're not going to do it as Lagrange, you know. It's just that A is given. So the firm is then just going to solve this problem, isn't it? Which then, the first order condition is what? The first order condition in Q. What's that going to yield?
16 minus 4q,
Equals
0.
the firm's going to set Q equal to 4, isn't it? And then, of course, we're going to miss the target, aren't we? But actually, it's kind of straightforward because whatever we choose for A, the firm is going to choose Q equals 4. So then we can easily find the level of A that must be chosen to give the target. So I bar is 4 minus 4, that's 0 plus 3A. So A needs to be 8/3. We need to set A to 2 and 2/3, don't we? That seems a bit weird. Oh, no, sorry, this is... Yeah, no, because this wasn't giving that level of I, was it? This is only giving I equal to... Oh, okay. Yeah, if I bar is 8, then we can work this out, can't we?
I think we did like that in the video you went through.
Yeah,
When we first came up with Q equals to 4,
yeah,
and then we used that to come up with that A has to be 8/3.
yeah,
So that was right.
yeah. I'm just trying to get my head around the relationship with this. Because on the optimum, this is saying that A should be, if I bar is 8, this is about a half, isn't it? So this is saying that A should be about 4,
I think it's supposed to say
Is this
6 over 19, right?
right?
Mine.
Okay. It's all these, yeah, 12 terms a month. Okay, thank you. All these careless mistakes make life really tricky. Well done. Thanks. Now it makes sense. Yeah. So, yeah, in the social optimum, it would be 6 times 8 is 48 over 19. And this would be about 3.5, wouldn't it? 48 over 19 is about 2.5. But if you put the performance standard on A alone, you end up with Q equal to 4 instead of 3.5, and you'll have to compensate by having a bigger A. So you'll have to make the standard for A higher, and it'll be more costly. So if you wanted to achieve the optimum through standards, you'd have to tell the firm both what to make, how much to make, and how much A to do. Then you could do it. Okay. So this is kind of important. All these ones where you let the firm determine the allocation of inputs or the allocation of its resources, and if we don't have inputs here, then it's going to turn out optimal. But if you start managing, telling it parts of what to do and giving it freedom on other parts, you're going to end up with a mess. Okay. And that should be reflected in your answer to part C. The social cost should be the same for 1, 3, and 4, but higher for 2. But the firm's profit, of course, is going to differ. The firm is going to love this subsidy, hate the tax, and the performance standard is going to be in between, right? Okay. Questions on that? No questions? So we spent a lot of time on that. What shall we do next? Do you want to take a break? Or do you want a break? Yeah? Quarter of an hour? Yeah? Okay.
Wasn't 1.3 and 1.4 quite similar? Or am I remembering?
A lot of them are pretty similar, aren't they? But yeah.
But maybe we can do 1.4 then.
Okay. I was kind of thinking that maybe we'd do 1.4. Let's have a look at 1.4. Okay. So what have we got? 1.4. Again, we've got a cost function. Whereas it would be kind of nicer to have a profit function with inputs, but we've got sorry, I got the wrong paper. We've got a cost function and weight. But we need to set things up in terms of profits, yeah. So what are profits in general? 3 words.
Revenue minus costs.
Profits, revenue minus costs. And what's revenue in 3 words?
P times Q.
Price times quantity, yeah. And yeah, and I got this wrong as well, didn't I, when I was doing the video? I was getting in all sorts of tangles on those videos. So as far as Vattenfall sees things, what is P? What can we say about P from Vattenfall's point of view?
It's exogenous.
It's just P, isn't it? It's like, it's not a function of Q. Even though we know that it is. So it's kind of odd. But you have to think of Vattenfall as actually being a representative producer. I don't know if you're familiar with that concept. Well, you guys are. You should be anyway. Have you heard of a representative producer? The other. Okay, so it's as if there are lots of identical producers, and then Vattenfall represents all of them, kind of. So they all have to have the same cost function and so on. I could go more into the math behind it, which is strictly then they're all actually infinitely small. And then you have this integral across. You have a mass, a unit mass of representative producers, which is as if you had one. But they're perfectly competitive because actually there's loads of tiny ones. Okay. So that's P. So help me, how do I carry on with this profit function? What shall I write next? It's obviously Q, we already said that, but what's Q a function of? It's a kuggfråga.
Q is Q.
It's just Q, isn't it? PQ minus costs. Yeah. Oops. And the costs we got over there. C plus Q minus E over 2 all squared.
Isn't it just the top part that is squared?
Oh yeah, thanks. I would have been in trouble again there. It's like this when I do research as well, my God. Doing this pages long derivations, and then I always make some mistake somewhere. Spend days trying to find it. Okay. I actually quite like this cost function. Has anyone got any idea why I like this cost function? Whereas, yeah, I'm not so keen on those ones. Some of the other ones in these questions I really don't like. Remember this thing, because here we've got, what are the units here? This is emissions, isn't it? And what are the units of this? Dollars per
Year.
yeah. But the point is, in general, things are going to be continuous. And if you want to cut your emissions a bit, on the margin it's not going to cost you anything if you're at the optimum. In general for firms, there's going to be ways for them to marginally reduce their emissions at zero cost if they're not already under regulation. If they're already being regulated, then they're here somewhere. And all the zero cost options have gone. Yeah. But if they're not being regulated at all, they should be able to reduce emissions at zero marginal cost initially. It's to do with the envelope theorem, or one way of thinking about it. Do you know what the envelope theorem is? Yeah. It's kind of a marginal adjustment. If you're at an optimum, a marginal adjustment in an unrestricted variable isn't costing you anything. And that actually holds here, right? That's kind of why I quite like this, unlike in a lot of the other of these problems. Okay. So, if we just focus on the information we need, what is the uncontrolled level of emissions for a given amount of electricity produced? Okay. So Q is electricity, E is emissions. Okay, so how are we going to answer part A? It's not going to be based on this, is it? Or is it? Like, how are we going to answer this?
First order information.
Sorry?
First order information.
Is that going to give us the answer? Perhaps it is. So why don't we'll take the first order condition in Q, and we'll get P. So are you all happy just differentiating something like this? Yeah. So we go outside and say 2 times this, C plus Q minus E, then we go inside and that's just 1. Over 2 equals 0, so that's that. And then the first order condition in E is going to give us, it's just going to give us that C plus Q equals E, isn't it? I can see that straight away. So what's this? C is just a constant, isn't it? So you can actually interpret this. This one actually you could talk about coal and gas and stuff if you wanted. What's really going on here?
So,
This is a sort of candidate. We've just sort of taken the first order condition, but we don't know if this is a minimum or a maximum or what it is, do we? So we need to think, like, why would you set E equal to C plus Q? Well, what happens when you set E equal to C plus Q?
The cost is free.
You have zero costs, don't you? So how can you interpret that in terms of coal and gas, say? Imagine C is zero, this C. So costs are Q minus E squared over T. E is emissions. Q is how much? You make. Actually, it doesn't quite work. But you could almost think, well, you've got sort of coal that's free and gas that's expensive. And if you use coal, you have emissions, but also costs. But if you switch to gas, the more you switch to gas, that gets rid of your emissions but adds to your cost. I'm not sure it quite works because of this square power, but okay. But anyway, this is clearly the minimum, isn't it? You want to let your emissions be equal to the quantity you make plus this fixed term. So that's the answer to part A. What would the social planner choose? Okay. So is this the social planner's problem? It's not, is it? The social planner wants to maximize the surplus, yeah. The social planner wants to maximize sort of social profit or whatever you would call it. You could call it whatever you like. But it's AQ minus B over 2Q squared minus costs. So this is the gross surplus from the product, but not including costs, yeah. So then we need to take the costs away. And we need something else in the social planner's problem, isn't there? The actual damages. Delta euros per ton, so it's delta times the tons. Minus delta E. Okay. So that's the planner's problem. And the planner's going to choose Q and E, isn't she? And then you've just got first order conditions and so on. So, what would the comment be on, I mean, this seems pretty straightforward. Yeah. So you're both going to have, both too much emissions and too much production. So in general, it's linked to this picture that if you want to cut production, if you want to cut emissions, one way of doing that is just to cut production. Yeah. So typically, if you start imposing emissions taxes on firms, among other things, they'll cut the amount they actually produce of the final good, as well as maybe having some kind of abatement effort, buying some other input.
Yeah, here is Q and E, they're not like linked to each other, because I would think that
Here,
Q is a function of E, because depending on how much electricity you produce, you'll emit pollutants. But here the firm can choose both Q and E, or is it like
Yeah.
somehow indirect how much they abate, or how does it really?
yeah, exactly. Or, yeah, you're thinking in the right way. That it's going back to these different ways of conceptualizing the problem. So here we're saying the firm chooses how much to make of the stuff and how much to emit. And to achieve, and it'll always be on this efficiency frontier kind of. And so if it decides to make sort of 10 and emit 10, say, that could be here, say. But then, if it decides to make 10 and emit only 8, then it must be spending money and buying some abatement inputs or something, or spending more money on buying gas instead of coal. But that's all kind of, what do you call that? It's like abstracted from the model. We can't see it in the model. But behind these equations, there's stuff like that going on about real inputs and real, physical choices by the firm. But there's no guarantee, if we just choose some arbitrary combination of Q and E, there's no guarantee that it's going to be on the frontier. But if we do first order conditions and things, then we'll always be on the frontier. Okay. So where do we get to? Yeah, we set up the firm's problem and we set up the social planner's problem. We'd solved this by taking first order conditions in Q and E. We haven't actually solved this, have we, yet? But in part C, we're told to compare uncontrolled emissions with the social optimum, so then we need to solve this. We know that E will be Q plus C, but then we need to solve for Q, don't we? And of course we'll find that uncontrolled emissions are higher than the social optimum, but under control, a bigger quantity will also be made in general. So why don't we do the Pigovian tax one? Since a massive part of this is learning to set up the problem. So why don't you guys just set up the problem for the Pigovian tax? Again, do it in pairs or whatever if you can.
So we have
Sorry.
Men det var tanken att
Ja. Jag tänker att man vill
Och så lägger vi bara till Taui och sen så... Så kommer det
Hur tänker du?
Jag tänker man lägger bara till Taui och Planner. Nej, jag tänker Firms Profit.
Vad är
De
det
får
för
ju... De får ju bara en tax och kommunen reglerar det. Det är de som är precis.
Yeah, that it should be social optimal.
Det ska det ju också. Men det kommer ju...
Planner makes it put herself in shoes.
Yeah.
How is the firm correct like that?
But
So therefore, which is yours, right?
I don't have it.
Yeah.
But don't you need to account for like social?
Then the planner needs to say, okay, now I know the firm's reaction function to my tax, so now I need, when I know that, I can now find the right tax
Oh,
to get the right behavior from the firm.
yeah. And that's one we know that it's like.
Okay. So this is super important, okay. In this case, it's a little bit krystat, it's a bit contrived, because you can just look at this and say, look, the tax is going to be delta, because you're going to set the tax at the marginal cost. But let's pretend we don't know that here, and think, in general, how is the regulator going to achieve the planner's solution, or the socially optimal solution? And the regulator's worked out, the regulator knows what the socially optimal values of Q and E are. We could call them Q star and E star. And we've worked those out in some previous part of the question, haven't we? Yeah, part B. So now the regulator is thinking, what level of tax should I set to achieve these? So what does the regulator do? The regulator needs to put herself into the firm's shoes, right? So what does that mean in practice? Anyone other than Hannah and Julia? What problem does the regulator need to set up? The firm's problem. So is that this?
Minus the tax.
Like that?
E as well.
Minus the tax payments. And then you're away. Because then you end up with, you take the first order conditions, so this is still the firm's problem. So the firm is not choosing TOR, the tax. The firm is choosing what? Q and E. So you take your first order conditions, and then you have like E equals da 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 da, and it's like some function of the tax. And Q might also be a function of the tax, I guess. Yeah, it will be, because Q is a function of E, which is a function of the tax. So you know Q star and E star, and then you've got these. So you just need to find the value of TOR, which delivers these. In general, of course, looking at this, there's no guarantee that there'll be a value of TOR that will give you both of these. But in this setup, we know that it will, because we know that an optimal tax can give the optimal allocation, which is this. see if this falls out nice and quick. So, if we take the first order condition in Q, we get that P equals, no, the 2 goes out, and then we just get C plus Q minus E. That's the first one. First order condition in E gives minus this lot minus, that's plus this lot, minus tau equals 0. So C plus Q minus E equals tau. Is that right?
Yeah.
So then if we substitute in here, we end up with P. No, that can't be right.
And then we put in the function for P. So we get A minus BQ equals tau.
Right, yeah. Yeah, I'm mixing up the questions. Yeah. Thanks. I had something else. I had P equals 16 in my head. That was some other question. So P is A minus BQ. Okay. Yeah, but that's still, if we substitute tau in for this, we still get the answer, don't we? Tau equals A minus BQ. So then we can put Q star in. And we should get the right answer for tau, which should then, and if we put E star in as well, it should come out as delta. Okay. I'm actually kind of, when I'm doing this now and getting a bit more of an overview of the whole thing, I'm really missing a question here from the perfect market situation. Like, what's the classic argument for Pigovian taxation or these economic instruments? Tax, subsidy, tradable permits. There's no question here that is capturing that, the classic story. What's the classic story about why Pigovian taxes are so great? The equimarginal principle. Have you heard of the equimarginal principle? This kind of picture. Do you recognise that? Yeah? Ian recognised it. Anyone else recognise that? What do you see in that picture?
I don't know, but I think like this line is the marginal damages or the tax.
It's the tax, yeah. So this must be dollars per ton or something here. And what are these? You don't remember? It's fine. But these are like the different firms' abatement costs. And if you put the tax in, so this is like abatement in sort of tons per year or something. So this times this is dollars per year. So an area on this is a cost, is it in dollars per year, you know, a loss of profits or something. And if you put the tax in, this firm abates this much, this firm abates this much, and this firm abates this much. Yeah. And we achieve, if this is like 1, 2, and 4,
And if the planner's optimum is to abate, what's this, 7 tons? Okay, so imagine we haven't brought damages into this, but let's imagine the planner's optimum involves 7 tons of abatement. What can we say when we do it using the tax? These are the only 3 firms on the market or in the sector. It's pretty straightforward, right? Why don't we stretch? Stretch the scale a bit and say it's 6 tons. The point is that doing it by the tax is efficient. Okay, we're achieving it at least cost because we're setting the firm's marginal costs of abatement equal. Imagine that we told each firm to abate 2 tons. What would the costs be then? It would be this firm's cost would be like that, wouldn't they? And then I'm looking for my red pen. I don't know what I did with it. Whatever. This firm's cost would be like this, and then the final ones would be there. And you'd end up with higher costs in total. And we could draw triangles and things and work out how much higher. But this is like the classic first year kind of argument for why the tax or a trade law bonus is so great, compared to just telling firms what to do. Because then you have this sort of Travelorn bill, you have this kind of idea that, well, telling firms what to do means telling them all to do the same amount of reductions, and then some of them might have high costs and others low costs, and it would be better just for them. So it would have been kind of nice to have a mathematical problem capturing that with 3 firms with different cost functions. And then looking at the planner's allocation, solving that mathematically, and then looking at what would happen if you just tell the firms to abate equally. Okay. So that's perfect markets. It's like all these questions, so much is about, found my pen, it's about setting up the optimization problem. But it's also, a key thing is when you're thinking about the planner's choices, you need to think, what is the planner doing? The planner thinks, how did my levers affect, oh, you didn't see my lever picture. How do my levers affect, or maybe you looked at the video. No, not yet. How do my levers affect the firms? And then based on that, how far shall I pull the lever to get the outcome that I want? Yeah. Okay. What should we do now? Give me a request.
one quite similar to the earlier, or was it just in the beginning it was similar?
It's exactly the same at the start, isn't it?
Yeah.
But then we introduce the market power. Oh yeah, the whole of the first half is just the same, isn't it?
Yeah.
That's a bit odd. Never mind.
I think 2.2 was a bit more trickier.
Yeah, 2.2 is surely trickier. Should we have a look at 2.2? Yeah? Okay. Just relax for half a minute. Or do you want to break now, or should we carry on with this for a few minutes? Carry on for a few minutes. So just relax for 30 seconds. Okay, so this one's quite messy, isn't it? So we've got n firms. If we're going to try and get a grip on this, what could you do? What could you do when you're told? You could think straight away. What could I do here if I'm told there's n firms? I would kind of think, well, let's just think of n as being 2. Okay. 1 is probably not going to be enough to capture what's going on, because they're going to be trading with each other and so on. But you might want to have a picture in your head or even on paper of, okay, let's just think of it as 2 for now. And each firm is given Z bar I. So they may be different, yeah? The subscript means that the endowments could differ between the firms, yeah? And those are permits to emit. And each firm has costs C of A1 is A1 squared, C of A2 is A2 squared. And laissez-faire emissions are E bar. So what's E1 in that case? So this is super important if you just to get your head around these questions, where you're given like abatement. Okay, if it's not trivial, you better talk about it to your neighbor. Yeah. The definition, I'm asking for the definition of E1. Okay, yeah. Okay, so I'm asking for the definition of E1. It's an identity. It's not to do with the permits. Okay. Hannah was talking about permits, which made total sense, but I realised I needed to be clearer in the question.
So, Elin got it, okay. In terms of just the definition of Firm 1's emissions, I had this great pen and I must have put it down somewhere. Yes, it's this one. Is E1, Firm 1 emissions is just E bar minus A1. Okay. So this is kind of establishing what we mean by the abatement here. It's not even totally clear. It could even, really, it should be defined what we mean by this. But given that it's not totally clear in the question, it's even more important to make it very clear to yourself and maybe to the examiner that this is how I'm interpreting what A1 is. Okay, and then obviously then we can, when the firm is actually acting on the market and assuming it's sort of obeying the law and so on, it's going to have to, there's going to be a link between this and this, isn't there? Okay. Okay, so we've got this firm. And it's got an endowment Z1 bar and emissions E1. And this other firm has got an endowment Z2 bar and emissions E2. And now I want to start putting some other restrictions on what, these are just given, aren't they? But what else must be going on? What else can we say about this? Best to go back to talking to a neighbour, I think.
Men just det, det är nu inte för att jag kan veta också. Om jag inte vet någonting eller inte någonting.
Till exempel E1 och E2.
Ja, men
Vad vet du om dem?
det är bara att fundera.
Om vi
Jag
tänker
vet
att
när
det
de
var
kommer
någon
in lite och då är det
så fick de
för
där
att du kommer ju släppa ut,
rättigheter.
du kanske släpper ut 10 och 5 av dem.
Och sen kan de sälja eller
Och de
köpa
500 får jag byta.
sånt där.
Men jag tycker att jag...
Så då kan vi stänga en hel del saker. Vi kan skriva ner några ekvationer som kopplar ihop
Typ att man sätter på en men 5 av dem, de bara går inte. För jag har
Det finns en superenkel ekvation som är
så då borde du bara vara...
man får inte släppa ut så mycket.
Om du kan ju välja.
Totalt sett.
Ja, det kan du göra. Men jag tänker själva relationen mellan de tre grejerna. Mellan så här att då är just E är lika med Z plus
Ja, så E1 plus E2 måste vara mindre än 1 eller lika.
E är lika med Z.
Yeah, because with this one, we just have to
Ja.
so
So
Så köper du ett argument.
There's a really, really simple thing we can write down straight away, which is this, right? Well, actually, strictly this, but in reality, it'll always be equality. So, did you guys get that? Or?
not completely, but I think we were
But do you,
heading in the direction.
yeah, do you see it now? Which is what I'm really interested in.
see where this is coming from?
The total emissions need to be smaller than
The permit, the
Yeah.
total permits.
Yes.
So they can't, and in practice they'll emit up to the limit. You know, the restriction will bind. So we can straight away write that down. And if we relax our restriction that n equals 2, what can we write then instead of this?
The sum of AI
Yeah.
is equal to the sum of ZI.
Right. In shorthand, you can write the sum over all the i's of the ei. Strictly, you would write I equals 1 to n here. So that's the full version of that, isn't it? But there's another thing that has to hold here. So imagine E1 is bigger than Z bar 1 or Z1 bar. What do we know then? The firms are following the law, kind of, or obeying the law. If E1 is bigger than Z1 bar, what do we know?
Add to a bit.
No. So E1 is how much they emitted. Aha, you're thinking like that. Yeah, no? I see how you're thinking now. But no, I'm saying they really do emit more than Z1 bar.
They have to buy permits.
Then they must have bought some permits, mustn't they? They never broke the law, and we observed them emitting more than their original allocation of permits. They must have bought some permits, yeah. So how many did they buy? It's like, I don't know, we should call it sort of Q1 or something. If we say Q1 is how many permits that are bought by firm 1. Talk to your neighbour again. Wait, I want something here. Q1 is defined as permits bought by firm 1. Okay. So Q1 must be E1 minus Z1 bar, isn't it? Okay. And in general, of course, then Qi must be EI minus ZI bar. Okay. So these are surely going to be crucial relations that we're going to need later when we get into the problem. So it could be a good strategy if you see this, just seeing this, you might want to start thinking about this kind of thing straight away. To sort of get your head round what's going on before you start trying to answer questions. I don't know. It's really up to you. But that's how I'm doing it now anyway. So now let's actually look at the questions. Derive a condition for firm I's emissions as a function of the permit price. Okay, so we need to make up some notation, don't we, and call the permit price something. So let's call it P. So, how are we going to, in general, answer this? What do we need to do?
But the profit maximization problem.
You could like record that, couldn't you? And play it up. And it's the firm's profit maximization problem. This is how you, all of these questions pretty much, once you've got the sort of, your head round what's going on, and then it's like, okay. So why don't you do that for me again, if you're happy to work 2 and 2, as the Swedes say, or with your neighbour, or on your own if you prefer.
So,
Something like this, yeah?
Stress me out. Sorry.
Oh, sorry. So, yeah, it's really hard when I'm looking at it.
Okay.
So the firm I with revenue minus cost.
Mm-hmm.
So what have you got?
Okay.
So your revenue.
Exactly.
Okay, yeah. But actually that P there.
Mm-hmm.
So that's the permit prices.
Okay. Yeah. Sure.
So we need to be a bit careful here.
Yeah.
Because
Exakt också
all we've actually got. Yeah. So all we've actually got is costs, isn't it?
Mm.
So in a way, we're not told anything about quantity and so on. So if we're going to do it this way, we would have to sort of say, well, there's some kind of pi bar. I can't remember if I did it this way I did. Okay, yeah. So we could have just said, look, it's a cost minimization problem. And we could have said the firm's costs are this plus purchases of permits. Or we could say, look, the firm's profits is like some baseline profits minus costs, yeah. So since Hannah said we should set up the profit maximization problem, let's do it that way, yeah. But and this is just a constant, yeah. So it's going to drop out straight away. Yeah, so we got pi bar, and then we got minus abatement costs.
Yeah.
So that's A squared,
Mm-hmm.
and then it's just, okay, getting your head around how many permits does the firm need to buy?
Yeah.
And you could write it down, initially you could write it down in terms of emissions, because that's what we got on the board there.
Yeah.
Then later you're going to have to then think about the link between emissions and vapors.
Yeah.
Ja, just för då byter du A mot E-barnens frihet. Ja. Och så väljer man det.
Yeah. Yeah, exactly. And then, yeah, we either need to change this into E's or that into A's. Okay. Good. So, firm I's profits are firm I's baseline profits minus firm I's costs, which are AI squared plus the permits that firm I needs to buy, which is this, isn't it? Times the price. Okay? But then we've got A's and E's here. And basically we know that these A's and E's are dependent on each other, aren't they?
We go with the I.
I can't remember what I did in the video. You could just choose whichever one you wanted to get rid of here. Or you could have a Lagrangian, but it would be pretty gratuitous. You might as well just substitute in here.
You could also have set this up as a restriction in